Welcome back to this class where we are talking about the usefulness of some named inorganic compounds, and we have taken the example of chromyl chloride. What is that? CrO2Cl2? CrO2Cl2 is our chromyl chloride, and that chromyl chloride is a very useful compound from analytical chemistry point of view also. But if we talk in terms of industrial chemistry, how we can make it if it is a specialty chemicals for some kind of conversion, and if it is prepared in a bottle, we can produce it and we can sell it to the market. But sometimes we find that these compounds are not so easy to preserve it, because it is a highly oxidizing compound. Because if you just look at the corresponding oxidation state of the chromium, it is chromium hexavalent compound, which should be highly oxidizing, like your potassium chromate, like your potassium dichromate. It has also a +6 oxidation state, because your 2O2 is giving you 2 O2 minus charges, so 4 negative charges along with the 2 chloride charges, making 6 negative charges in it. So, this chromyl chloride species, if we can form it very easily in the laboratory. So, this is the bottle which has been giving you some red liquid, and this red liquid is nothing but our chromyl chloride molecule, and that chromyl chloride molecule is formed from a reaction of a compound which is nothing but your compound in the hexavalent state, and we have to use for its corresponding chloride concentration. That means the chloride should also be available in that particular reaction. So, what we will see that what that particular type of reaction we can get for the production of chromyl chloride, that we will see now is from that of the reaction of K2Cr2O7. So, if we can have, so this is our K2Cr2O7, and that K2Cr2O7, if we use it to react with NaCl along with sulfuric acid. So, this is a typical example, because we will not be able to give you all the different types of reactions what we can use. So, this is also a hexavalent chromium, and you can have the corresponding availability of the chloride, because we will be talking in terms of the corresponding formation of Cr double bonded O, Cl, Cl. This is our chromyl chloride, which is our lead liquid. So, you have 2 chromium. So, definitely we will be able to produce 2 of these chromyl chloride, which is a red liquid, and we should produce it in situ, that means within the reaction medium. So, in situ preparation will take place from the reaction of potassium dichromate with sodium chloride, because this is the source of this chloride which is attached to this particular chromium center, because this particular reagent is a very good reagent. What sort of reagent? It would be highly electrophilic. As well as aggressive oxidizing agent. So, if we consider in terms of organic chemistry that we can go for some electrophilic substitution reactions or electrophilic other types of reactions, we can use this particular reagent. So, this we have seen that this potassium dichromate preparation from any chromium ore, if we consider that we will be able to make it from a chromium ore, that would be an interesting thing. That means it can give you the value addition, because the chromium ore what is available to us will be the bulk material, bulk inorganic material, which can be purified for this chromium dichromate preparation, and sometimes we can go it through K2CrO4, that means potassium chromate form. So, once we make through the direct oxidation, that means sometimes in the laboratory we do it through alkali fusion reaction, and that alkali fusion reaction convert this chromium ore, which can be your simple chromium oxide CrO3 or Cr2O3. Chromium in the trivalent state, the corresponding oxide in the trivalent state, or chromium in the hexavalent state can be our ore material. So, as we all know that the different metal ions available on the earth crust or the earth mantle, just we have seen in our previous class that those materials are available as the typical oxides, and how we convert it to some useful organic compound. So, this potassium chromate and the potassium dichromate will be your useful material. So, it has some amount of specialty material from the bulk material, which is our own material, and this can be useful for identifying your sodium chloride. So, it can give us the identification of chloride ion. So, chloride ion identification. So, is a part of this particular one is a typical analytical chemistry. And as we all know from our laboratory analysis that this is a part of your qualitative analysis. So, qualitative analysis, if we want to identify the chloride ion, we can go for this particular reaction again through the use of our bulk inorganic material. So, bulk inorganic inorganic material, bulk inorganic material, sulfuric acid. So, we have to use the sulfuric acid. So, you see that how we consume sulfuric acid from simple laboratory to the industry. So, if we are able to produce some of these compounds where sulfuric acid, because the maintaining acidity of this particular reaction is also important, and maintenance of that acidity for that particular one is only from sulfuric acid, not from hydrochloric acid or not from nitric acid. So, because these sulfate ions can have some important role and interesting role, because when we talk in terms of the corresponding chromium in the hexavalent state, we always try to understand that it is the hexavalent state is highly oxidizing, and when we are labeling this molecule as highly electrophilic as well as aggressive oxidizing one, so we should not use any other inorganic acid or mineral acid like hydrochloric acid. Why not? Because we know that hydrochloric acid will have the corresponding chloride ion. So, that chloride ion from the acid source, if it is available for this particular one, is going for its oxidation, but at the same time we should also remember that we have plenty of these chloride ions, but it can go very nicely with the sulfuric acid because of the presence of this sulfate anion, though the sulfate ion is not taking part in this particular reaction. It is the chloride ion which is available from the other solid salt, inorganic salt like sodium chloride, to giving us this particular one, and this chromite chloride is forming along with what other thing it can form, because it can have the corresponding one as 2 molecules of potassium bisulfate. So, when we make this as a red liquid, we have to go for its corresponding potassium bisulfate formation. So, if we take hydrochloric or nitric acid, we will be ending up with potassium chloride or potassium nitrate, but the separation of these from the material cannot be sometimes so easy. So, we will end up with some other problem. So, this potassium bisulfate, again this sodium will be consumed as your sodium bisulfate. So, this can be used as twice NaHSO4. So, this sodium can go for like this and plus 3H2O. So, these are some reaction balance type of things. So, what we get is that your red liquid which is forming in situ is our chromial chloride, and which is very much similar to the corresponding analog of sulfuryl chloride, as we all know that this is the corresponding one. So, is reactivity pattern, that means there is a electrophilicity and is typical oxidizing agent. So, it has some behavior which is similar to that of our sulfuryl chloride, and is a typical one for the identification of the chloride ion. then it can be distinguished for some other salt, or some problem is there for industrial problem, that if we can have the typical identification of the chloride ion in presence of other halides, which are fluoride, bromide, iodide and cyanide. But presence of these four, that means instead of sodium chloride, if we can have sodium chloride, sodium bromide, sodium iodide or sodium cyanide, whether we will be able to get the corresponding type of compound where the chromium center is attached to fluoride or attached to cyanide. But this is not happening, because the same reaction, the laboratory reaction, is not forming any red fumes. So, no red fumes are formed. So, that is very interesting. So, the attachment of this fluoride, bromide, iodide or cyanide to this particular chromium center as to the adjacent CrCl bond is not possible, because the fluoride, bromide, iodide, those can be oxidized or those can be converted to some other form. So, this particular reaction, that means the corresponding chromyl chloride formation from any other chromium source, is only useful for making this chromyl chloride reagent, and which can also show us that how we can go for a particular type of specialty molecule for our useful purpose. So, what is that purpose? Red fumes as your chromyl chloride formation. So, this chromyl chloride formation, we should be prepared it in situ, and then we can use this particular red liquid for other purpose. So, the person who first utilized this for some useful purpose like that of oxidation of terminal alkene to aldehyde was the person, the scientist Ettard. So, scientist Ettard, when he used this particular one for some useful purpose, is known as the corresponding Ettard reagents. But naming this thing is also remembering that particular person, but we should not forget the corresponding composition of this particular material is a very simple one, which is a test for chloride ion, the chromyl chloride formation, the red fume formation, and we should also know the corresponding molecule very nicely. So, the understanding of basic inorganic chemistry is a base for understanding this particular reagent, which we can produce in the industry as a typical inorganic compound, inorganic material, because this particular reagent can be useful for the oxidation of terminal one as well as the internal alkenes also, because in case of internal alkene it gives alpha chloroketones or related olefins. So, what we see now, that previously we are talking about the oxidation of terminal alkenes to aldehydes. So, if we can have terminal alkene, or if we are able to make it some amount of terminal alkene from some alkane also, that can be converted to the aldehyde, because the conversion of the typical alkane type of thing to aldehyde is not always easy, and always we try to go for this particular reaction, that how easily, how quickly, and the process should be a cheaper one also in terms of our man-hour investment, our labor investment, our material investment, our time investment. So, if very easily we can convert it to aldehyde through this particular process, we should utilize this particular process for this oxidation. But now, if our substrate for that oxidation reaction is changing from terminal alkene to internal alkene, what we see now, we get alpha chloroketones. That means whatever we are getting similar to that of keto molecule, that means instead of aldehyde we are getting now ketones. But it is also supplying the chloride ion. That is why we are seeing that how useful is the attachment of that particular chloride ion. That means the involvement of that particular oxidation state of chromium as the highest possible oxidation state is not only the only thing which can be useful for this purpose. Otherwise, we could have used chromate salt or the potassium dichromate salt. These are also oxidizing, and these are all having chromium with oxygen, double bonded oxygen. But attachment of these two chloride ions to the chromium center gives us something very different. So, alpha chloroketone or any other related derivatives or the compounds we can make through this reagent. And also it can attack benzylic methyl groups. If you can have the corresponding benzylic methyl group to give aldehydes, like if you can have only CH3 function attached to the phenyl ring, we can have the corresponding reaction since the reagent is used by his name. So, the reaction can also be considered as the Itard reaction. So, what is that reaction? Let us see that reaction from a typical organic chemistry point of view, because small organic reactions we should also know when we are utilizing this particular chromyl chloride. So, what is Itard reaction? Itard reaction is nothing but if you have methyl substitution on the phenyl ring. So, if you can have only that corresponding one as a methyl function attached to the phenyl ring, we can get this corresponding oxidation to the benzaldehyde formation. So, how we can make or how we can convert the bulk amount of this hydrocarbon to the benzaldehyde? So, if the easiest or the simplest process is through the use of chromyl chloride, we can go for this. And since we are talking about something which we considered is as the corresponding formation of the terminal in, so we can consider it when the reaction is taking place through this is that corresponding in formation, in molecule formation. So, we consider it as the in reaction, and this can happen only because this was CH3 and this can be converted to CH2 because this particular hydrogen, the hydrogen from the methyl group can be taken up by the corresponding chromium oxygen bond, that means this oxide ion which is attached to the chromium center, converting it to O2OH. So, the abstraction of this particular hydrogen ion is very easy by this particular group, and still the chromium, if it is attached to that particular carbon center, which can consider as the carbon chromium bond, which is a typical process or procedure which is going through some organometallic pathway, because it is sometimes difficult to identify that at least you are getting that particular chromium carbon bond formation. Instead, what we can propose that as an intermediate and a very unstable intermediate, it can form this particular species through the abstraction of this hydrogen. One of the CRO bond is converted to CROH, other is remaining as a double bond. In the second step, this particular one can attack again the corresponding in function, and the attack of this particular in function through the other double bonded oxygen will give you some carbon oxygen bond formation, which is the basic requirement for our conversion to benzaldehyde. Because what we are looking for, we are simply looking for a carbon oxygen bond, that means the carbon oxygen double bond formation for aldehyde formation, and sometimes we can go for the ketone formation. That means wherever we go for the aldehyde or the ketone formation, we should go for the corresponding carbon oxygen double bond. So, initially when this is present, it is like that of our formation, that means it is there, you have the corresponding one as the CH2. So, CH2O, which is attached to the oxygen of the chromium center of chromyl chloride. So, then this hydrogen can be abstracted back by the Cl minus which is present over the chromyl chloride, forming our HCl in the medium. So, this HCl formation from that particular medium is useful then, and that is also when it is abstracted, then it is going back to give you the corresponding aldehyde. So, you get that. So, once you get it as the, because this particular interaction will give you that transfer of this oxygen. So, chromyl chloride is basically transferring this oxygen from its reagent form to the substrate molecule, giving you the corresponding benzaldehyde formation, and the remaining part is stays like that of your chromium salt, because the chromium, if it is reduced, you will get the corresponding chromium compound in its lower oxidation state. So, that gives us a very useful example of utilization of a chromium compound, and that utilization of chromium compound from making some useful molecule and some useful organic transformation, and that gives us some good idea how we can have a bulk or commodity material like our chromium oxide as the ore material can be converted to some simple sophisticated material which can be called as a specialty chemicals like that of our chromyl chloride. Now, we move on to the species. What we will be talking now is the different bulk material which is available in a large amount from different sources like water. We have already discussed little bit about the usefulness of water molecule, which can be the very useful molecule for inorganic industrial chemistry. So, not making the potable water molecule or not making the drinking water molecule, this is another aspect, but how we can utilize the different types of water, even the recycling of water, rainwater to ocean water, how we can utilize for different or useful purposes, because this simple water molecule can function as a very useful solvent. As we have just seen all other reactions what we do in water media, because most of the inorganic compounds and inorganic chemicals like that of our sodium chloride, which we use every day from our kitchen to laboratory, which is highly soluble in water, to any organic molecule like our dextrose, the sugar, which is soluble in also in water. So, if we consider we can make some saturated solution of sodium chloride in one hand and sucrose in the other hand, we will be utilizing the water molecule. So, what type of water molecule we can use this as the solvent? So, different types of inorganic reactions or organic reactions which we can utilize for making some useful compound. So, from industrial point of view, how good is the water as the solvent? Because for making all these molecules in the greener way, because we all know we will be very much concerned about the environment, which should not contaminate or destroy the environment by making some harsh solvents for doing some reaction. So, sometimes we call a reaction which is solvent free reaction. So, if we consider this as the solvent free reaction, means that we are not using any organic solvent like chloroform, like dichloromethane, like acetonitrile. So, we will be trying to utilize this only on alcohol like solvent which is more friendly, environment friendly, or water, or sometimes without solvent, that means the solvent free reactions. So, those are the things. So, making water, studying water and doing some reactions on water, always will be treating water as a solvent. Next thing is that how we utilize this as the reactant. So, so this reactant, what we can use this as a particular reaction, that means what we have we give you the example of reaction of sulfur trioxide with water for giving you the formation of sulfuric acid. So, the formation of this particular sulfuric acid will be useful for giving this water as the reactant molecule. So, starting from solvent to reactant. So, production of sulfuric acid will be dependent again on the quality of the water which can be utilized as the reactant for that particular reaction. Then we can have water as the solute also, because sometimes if it is used as a very small amount, water can also be useful for as a solute, and finally water can be utilized as a catalyst, because some of these organic reactions or the pharmaceutical reactions can be governed by catalytic amount of water. So, if one drop or less than one drop or 1 microliter of water can be useful for giving you some useful conversion, in that particular case this water can be useful as a catalyst. So, what we see now that water which is forming in many vital processes, a wide array of purification techniques has been developed, how we utilize or how we can purify the water. That means the quality of the water, as I told you, the extreme purification what we can have in our hand is the distilled water, where we can have only H2O, not even D2O. That we will consider that how we can get that D2O also when we talk in terms of the production of water, because following this we will be considering the production of hydrogen, then hydrogen peroxide, and then the other peroxide compound. So, these are the few things for all these classes what we will be talking in terms of the hydrogen only, because the availability of the hydrogen, unlike your nitrogen or oxygen, is not much in the environment, but that is available as the compound only, like water. So, how we get a good quality of water and how we can produce hydrogen from that particular water, that is our ultimate goal. That is why we should study little bit about the water molecule. So, this purification technique has been widely developed and people are trying for development of all these things for getting good quality of water. So, this water can be your typical starting material for as a raw material for different types of industrial processes. So, these different types of industrial processes what we can have, as I already gave you the typical example, which is sulfuric acid production. So, if I now say you tell me that which particular material can be useful for sulfuric acid production. So, already we know the brief outline of the sulfuric acid production, starting from your raw sulfur material, starting from the raw sulfur what we get from the ore, which can be utilized for useful sulfuric acid production, because the quality of water molecule is very important for the production of this sulfuric acid, because when we produce sulfur trioxide, that sulfur trioxide can be trapping your water molecule, giving you H2SO4. What does it mean therefore? That your H2O from water, H2 from water and the whole H2O molecule itself is going to your sulfuric acid. So, directly the amount of water what we are getting, the purified water molecule in your hand is directly converted to your sulfuric acid, and that sulfuric acid will be utilizing for different purposes as well as for supplying the sulfate ions also, because we will be producing other species based on sulfuric acid, such that if we want to make sodium sulfate or sodium bisulfate. So, that also utilizing the same sulfuric acid. So, the sulfate anion, and ultimately if we are trying to make barium sulfate. So, that sulfate molecule what we are in our hand, one of the oxygen of that sulfate ion is still coming from that water molecule, because we have used sulfur trioxide and the other oxygen is given from your water molecule. So, the water molecule is being fixed as the typical sulfate ion, and that can be utilized for all other different purposes, starting from getting sulfate for barium sulfate formation, and is a standard material for the water turbidity measurements also. Similarly, we can have the phosphoric acid production, because it is also H3PO4. So, if we consider that okay, again we are having something which is coming directly from the water molecule. So, we will be utilizing it for the phosphoric acid production as well as. So, these are the industrial areas basically where we can produce sulfuric acid in a large amount, we can produce phosphoric acid, then sodium hydroxymethyl sulfonate production. These are little bit high end sophisticated molecules that we will also see from one after another. Then we can have the chloralkali process. The chloralkali process is nothing but the electrolysis of sodium chloride, because the sodium chloride we get in a large amount from seawater, from all other sources like that of our Chile saltpeter, what we know from our school days. That electrolysis of sodium chloride will give you some useful molecules, and that is being done in presence of water only. Then we will just see, because these are only some collection of the name reactions or some name processes which will be utilized for our journey for studying this industrial inorganic chemistry. We will be studying Ostwald process also, we will be studying the Solvay process, we will be studying ilmenite process, and ultimately the gold cyanide refining. So, all these processes, if we say consider 1, 2, 3, 4, 5, 6, 7, 8 processes, and all these processes are dependent on water. So, if we consider we are dealing with some water industry, so is also in some way it is also true, because we should also be very much concerned about the quality of the water what we will be utilizing and the amount of water. So, the what quality of water, whether we will be utilizing the distilled water or simple ocean water or simple river water is sufficient, because we all know that anything where we produce electricity, there also we require water. Anything which we get the corresponding furnace, the cooling down of the furnace is also, because the water has large number of utilization, that means as a reagent, as a solvent, or some other as a heat sink also in other cases, which can drain out the excess temperature from the industrial processes. So that can also be seen in a stepwise manner from one after another for different things as we proceed for this particular type of course. Okay. Thank you very much.